Welcome to lesson 40. Brute force approach to solving systems of equations. Remember, the mission that we were on was to find a recipe that we could follow to solve any system of equations, right? In lesson 39, we were doing Kramer's rule, which was kind of nice. It was a recipe. You could say, hey, you got a system of equations? Great, here's the solution for x. The problem was it was in terms of these things called determinants, which were not really easy to do unless you had like a 2x2 system. That wasn't bad, but if you tried to do a 3x3 or a 4x4, it got to be impossible real fast. So it was a nice way to do it in a way, but it wasn't nice because it wasn't practical. So we move on to something else. This is something else, by the way. I might as well let you in on the secret. This is going to be something called Gaussian elimination. Gauss was the name of a dude, math dude. Gaussian elimination, and that's what we will actually be doing in 40B. I'll give it the official name, Gaussian elimination, and we'll follow it in its official way. The purpose of 40A is to kind of give you the background so that you can actually understand 40B. This is the background. This is how we're going to take our approach to making a recipe. Okay, so the first thing we want to do is we want to standardize the problem statement. In other words, usually we're going to have some specific example, right, that we want to solve. I want to solve that particular system, the 3x plus the 6y equals to 12, and so on. Well, in order to talk about a general system, a system where these numbers could be 3, 4, 5, 6, negative, whatever, we want to give these coefficients down here, we want to give them names. So here's our naming convention, naming the coefficients. So the coefficient of x, right there, is called a sub 1, 1. Notice the coefficient of y right here is called a sub 1, 2. Here's another coefficient of x, but this one's called a sub 2, 1. Here's another coefficient of y called a sub 2, 2. What is these numbers doing here? Well, a sub 1, 1 means the coefficient, first row, first column. First row, first column. It's going to be a coefficient of x, but it's the coefficient of x in the first row, first column. Now, first row, you could also call that the first row, but you could call it the first equation as well. It's, the first equation is in the first row. You put the second equation in the second row, and so on. So it's the first equation, first row, first column, which kind of means your first variable, x in this case. A sub 1, 2 is going to be this coefficient because it's in the first row and it's in the second column, right? First row, second column. And then, now these are coefficients for the x's and the y's here. So this is second row, first column. It's the coefficient of x in the second equation. Second row, second column. That's the coefficient of y in the second equation. When we say, equals, something x plus something y equals, we call those b's, just to say, hey, those are over there on the other side. Those are b's. But b1 for the first row or the first equation, b2 for the second row or the second equation, and so on. It's easier just to look at it than it is to listen to me explain it, really. The a11, yeah, that's that number. The a21, yeah, that's that number, and so on. So anyway, that's how we name our coefficients. Now, the way this is going to work is we're going to follow a process, and I'll show you the process in a little bit here, but we're going to follow a process that takes our starting point, whatever the general 2x2 system happens to look like, whatever these numbers happen to be, all these coefficients, whatever they happen to be, and we're going to kind of play around with it until we can simplify the system to have this kind of a shape to it, where notice there's no x here. There's no x there. Notice also that this is just 1x. It's just a 1x. We don't have to say a sub 1, 1 because we're just going to have it be 1. So we're just going to have basically y equals some number over here, and we're going to have x plus some number, y equals some number. So we're going to simplify that system so it looks like that. Now I must emphasize, in fact I'm going to emphasize it with an emphasizing color. This and this, not the same. This number, not the same. This number, not the same. These things are going to change as we go. So B2 is just kind of like the name for the number that goes there. B1 is the name of the number that goes there. A12 is the name of the number that goes there. They're going to change. They're not going to be the same numbers. So that's not what I mean when I write this second formula here. Okay, so those are not the same numbers. Let's put that back. But why is this a good thing to have? Well, because look at the bottom row. The bottom row is one of your answers. That's not bad, right? Oops, no. Why am I saying y2? I don't have to say y2. Y is going to be whatever that number is, b2. That's a solution. That's half your solution anyway. In order to get x, you have to plug into this equation, which is a nice equation. X plus, you put your whatever that number is, and then you would put your solution for y, which is that, equals b1. And so you can very quickly have a solution for x as well. Okay, so this looks better when you actually do it as opposed to looking at me make a formula for it. But so our mission, we're going to be given some general 2x2 system of equations. We're going to do some monkeying around with it to make it take this special form. Okay, how does that happen? How do we take that special form? How do we do that? Well, we do a series of what are called row operations. And the good news is the row operations are standardized. It'll work every time to do this row operation, and then this row operation, and then this row operation, and then we will be like so almost done. So, to see this in operation. Okay. What is this saying? Capital R1, maybe I'll write this up here. Capital R1 means make a new row 1. Okay, capital means make a new row 1. Little r1 means use the old row 1. We're getting ready to change row 1. Right now, row 1 is this. Right now, that is our old row 1. We're going to make a new row 1, which we're going to call capital R1. Okay, so we're about to change this little system of equations. We're on our way towards the simplified form we were looking at. So, okay, row 1 is going to be my new row. Take the old row and do what? Take the old row and divide it by this, a sub 1, 1, which means whatever number happens to be right there, right? Remember, first row, first column. Whatever number happens to be there. So what does that look like? I'll put a little asterisk here. What this looks like is, row 1 is, take the old row 1, so I'll just copy that, 3x plus 6y equals 12. And to divide it by, in this case 3, divide it by 3 really means, divide your equation by 3, which of course you divide everything by 3 all the way across your equation. So what's the new row 1 look like? Well, 3x over 3 is just x. Here, 6 over 3 simplifies to just 2y. And then we've got 12 over 3, which is just 4. So that's our new and improved row 1. And what you'll notice is that we just succeeded in getting a 1x, which is what we wanted, a 1x. So that's cool. What about the second row? Well, we didn't change it, so what we do is we copy it. So that's the old row 2. Just, it's the same. It hasn't changed yet. Okay. There, we just did a row operation. And what did it accomplish for us? We now have a 1x. If I scroll up, remember that's what we wanted, a 1x. Well, we got a 1x. Cool. What else do we want? We want nothing here. We don't want that there. We don't want x there. So that means we have to somehow play with these two equations and make x go away. And that's the story behind this row operation. What is that telling us to do? So let me kind of go like this maybe. So this is telling us that the new and improved row 2, the bottom equation, is going to be take negative, okay, this. First of all, negative. Don't forget the negative. A sub 2, 1. Second row, first column. Second row, first column is this number, right? Second row, first column. Notice that when you're making these row operations, you're always working with what you just finished making. Okay, so you're always working with, I'm not looking up here anymore. I'm done looking up there. I'm looking to the last thing I just wrote. The last system I just wrote is here. I'm looking over there. So a sub 2, 1, again, that would be the 2. So it says to take a negative 2 times row 1. So again, I'm looking over here at row 1. Row 1 says this, x plus 2y equals 4. And then I'm supposed to add to that. So you want to think in terms of we're adding two equations together. Add row 2 to that, which means add 2x minus 5y equals 1. So just to emphasize what this looks like, i.e., so when you multiply the negative 2 times this equation, you've got a negative 2x minus a 4y equals a negative 8. And then the bottom equation is 2x minus a 5y equals a 1. And when you add these things up, notice the x's go away. You've got a negative 9y equals a negative 7. And that's what you're writing as your new row 2. Negative 9y equals negative 7. And we succeeded. There's no x term. That's what we were wanting. What about the first row? Well, it didn't change, so just keep it the same as it was on our last step. Okay, so the idea of this row operation was to make a 1x. The idea of this row operation was to make this into a nothing. We wanted to get rid of the x. How do you get rid of x? You have to add equations together. We've done this, right? Add equations together. Okay, now our remaining goal, our target now, is to make this into just y. So maybe you can see what we're doing here. We're going to take the old row 2, in other words, we're going to take this equation here, and we're going to divide it by a sub 2, 2, which is this. Take the negative 9y and divide by negative 9. That's how you turn it into a y. So our new and improved row 2 will be take the negative 9y equals negative 7. Maybe I should make that a colon. Divide everything by negative 9, both sides. Kind of don't like the way that looks. And what you've got is you've got y equals 7 ninths. 7 ninths. So my new and improved bottom row is going to be y equals 7 ninths. The top row does not have to change. Now, in some sense, we've arrived at our answer. Not quite, but that's pretty much our answer. That was the simplified form we were looking for. So scrolling up again to take a look. Let me get some of this goop out of here. So we wanted to have this kind of a shape. X plus some number y equals some number. Y equals some number. That's what we got here. We got x plus some number y equals a number. We got y equals some number. Perfect. Having reached that point, this is almost an anticlimax. We can actually write our solutions. First of all, just look at the bottom row. It has the solution, y equals 7 ninths. That's half your answer. And it's not bad here to get your answer out of this equation. You just plug the y into it. So x plus 2y, except y is equal to 7 ninths, so we can plug that in, is equal to 4. So to finish this up, what do we got here? We got x plus, that would be 14 ninths. 4 is the same as 36 ninths. And so x is 36 minus 14 is, 22 ninths? Okay, and there's our solutions. X equals 22 ninths. Y equals 7 ninths, and it matches what I got before, so we're in good shape. Okay, so yeah, it's a little bit of a process, right? We've got a lot of different steps to do, a lot of different steps to follow, but isn't that what people usually like? They like to have steps. Just tell me the steps. Okay, I'll tell you the steps. Here's the steps right there, and we got the steps. Okay, now we just got to get used to the steps. Let's go through this again. By the way, it's very valuable to have discrete steps like this because you can tell a computer, hey, just do this, do this, do this. Computers are very good at following precise instructions, right? Although nowadays with artificial intelligence, who knows what's going to happen. But for a while there, you had to tell the computer exactly what you wanted it to do. Anyway, let's see. Let's go through this motion one more time. Here's our starting point. We're beginning with this system of equations. So at the moment, a sub 1, 1 equals 4, a sub 1, 2 equals negative 5, b sub 1 equals 4, a sub 2, 1 is equal to 3. A sub 2, 2 is equal to 2. B sub 2 is equal to 3. Now that's only at the moment. Like I say, these are all going to change. You know, by the time we get to our finished system over here, those are all going to be different numbers, or maybe not all, but they probably will all be different numbers. So let's start changing them. So the first thing you do is you change row 1. Row 1, take the old row 1 and divide it by a sub 1, 1, which is 4 in this case. Look what we're doing. We're taking this equation and dividing it by 4. The reason we're dividing it by 4 is because we're trying to make this into a 1x. Right? That's the whole reason we divide by that. So when we do that, 4x divided by 4 is x, minus, that'll just have to write that as a 5/4 y, equals 4 over 4 is 1. Cool. I did not change the second row, so we'll just copy it. So notice at this stage of the game, already, these are no longer, it's no longer the case. I didn't change these coefficients yet, but these coefficients are all different now. So the reason I'm pointing this out is because when it says grab A21, it doesn't mean grab this 3. It means grab this 3. In this case, they're the same, but you want to always look at your previous result to figure out what are these numbers they want. A sub 2, 1. They want that. Now, what are they doing? What are they asking us to do here? They're asking us to take negative 3, because it says negative of that number, negative 3, multiply it by row 1. So row 1 is this, x minus 5/4 y equals 1. And then add the next row, which is 3x plus 2y equals 3. Can you see what the idea is? Like, why are they asking us to do this? They're asking us to do this because look what's going to happen here. That's going to be a negative 3x, and when you add, you're going to get a 3x. It's going to go away. You're not going to have x anymore. That's the plan. Make the x go away. So I don't think I want to do this in my head, so I won't. So let's write it down here. Negative 3x. So I'm just distributing here. Plus 15/4 y equals, and then negative 3 times 1 is negative 3. Underneath, tuck that other equation. Oh, this is fun. So those go away, right? 15/4, 2 is the same as 8/4. So you're getting 23/4 y, and then this is nice, it equals 0. That was awfully sporting of whoever set this problem up. So that was, what did we do? We just made a new row 2. Maybe I'll just kind of get this out of the way so it doesn't bother me so much. So the new row 2 is going to be 23/4 times y is equal to 0. Row 1 is the same as it was in the last step. We didn't change that one. Okay, cool. Making progress. Final step. The second row, we're going to change it. We're going to divide by that coefficient. Second row, that coefficient. We're going to divide that by that coefficient. Can you see why we're doing that? I'm taking the 23/4 y and I'm dividing by 23/4. That way it's just y. I just want a y here. And by the way, 0 divided by that is still going to be 0. So that's kind of convenient. And so here's our finished system, our finished simplified system. That's a nice system. To find the solutions, all we got to do is you start by looking at the bottom row and you say, oh, y equals 0. There's one of my solutions. It's half my answer already. And then you come up to the next row and you plug that in. So x minus 5/4 times y, but y is 0, is equal to 1, which means x equals 1. Groovy. It is definitely a step-by-step approach we can take. We can do this with a 3x3 system too. We should do a 3x3 system just to sort of, well, notice I didn't write down what the row operations were. What I'd like to do in this one is have us see if we can figure out what the row operations should be. So what should I do? Well, first you want to make that a 1. And by the way, our basic way that we fly is we kind of move this, and then this. We make that an x. We make that a nothing with a y, and then we make a z like this. Okay. We want to have nothing underneath the x. Zeros underneath, if you want to say it that way. Okay, so anyway, we start up here, and we say I want that to just be x. So I want to divide that by 3. So the row operation I'm going to do is I'm going to do the new and improved row 1, and I'll just write it this way. I'm dividing row 1 by 3. Right? A11 is 3, but I don't have to say A11. I can just say divide it by 3. I'm dividing it by 3. Here we go. So 3x over 3 is just x. Minus, that would be a 1/3 y, because I'm dividing by 3. That becomes a 1/3 z, and that becomes a 10/3. The next 2 rows are not changing yet, so I just copy them at the moment. Pretend this is like we're writing down the computer's memory bank, and we just rewrote the computer's memory for this row, but the computer's memory is staying the same for these 2 rows. At the moment, it's staying the same. Now what should we do? Maybe I'll alternate colors. Well, following this idea that we should come down, we should try to make that x term go away. Now to make an x term go away, you want to add equations and then have equal and opposite coefficients. So what we're going to do then, and this is just a standard way of doing it, right, is say, well, if that's a 2x, I would like to have a negative 2x here. So I'll take negative 2 times my row 1 and add my row 2. Let's get that out of there. Okay. Which means what? It means I'll take negative 2 times row 1. Let me just do that. Negative 2x. Negative 2 times the next term will give me plus a 2/3 y. Right? So I'm multiplying across this row. Negative 2 times 1/3 z is going to give me negative 2/3 z. And on the right, when I multiply negative 2 times 10/3, I'll get a negative 20 over thirds. Okay, and so my new system right now, oh wait, and then I'm supposed to add row 2. Whoops. So that's that, and then row 2 is the 2x plus the 3y plus the 4z equals a negative 1. So the x's go away. That was the goal. 2/3 plus 3. 3 is 9/3. So we get 11/3 y. Negative 2/3 plus 4. Well, 4 is 12/3. So that would be a 10/3 z equals negative 20/3 minus 1, which means minus 3/3. So it's a minus 23/3. Okay, cool. Maybe what I'll do is I'll do the work in that color, and then here's the new result now. We left row 1 alone, so I'm copying it. X minus 1/3 y plus 1/3 z equals 10/3. But we just decided we were going to change row 2, and it is now 11/3 y plus 10/3 z equals negative 23/3. And the bottom row is still what it was, 4x plus 2y, minus 3z equals negative 1. So that's my system at this point in time. Next target, get rid of that x. So we're going to change row 3. How are we going to do it? Well, I want to add 2 equations together to make it go away. Well, the equation I want to add, of course, is this one, but I want to make that x into a negative 4x. So you take negative 4 times row 1 and add row 3 to it to get the new row 3. Get that out of the way. So that's that going to look like? Negative 4 times row 1 is going to be negative 4x. Negative 4 times negative 1/3 is positive 4/3 y. Then I'll have negative 4/3 z equals negative 40 over 3. That's this whole row times negative 4. And we're adding row 3 to it, which is 4x plus 2y minus 3z equals negative 1. So the x's go away, boom. 4/3 y plus 2y, that would be like a 6/3, so that's giving me a 10/3 y. 4/3 minus 3, 3 is like 9/3, so that would be a negative 13/3 z. And then negative 40/3 minus 1, which is 3/3, gives me a negative 43/3. Okay, we can write our new and improved little set here. So the first equation we didn't change. The second equation we didn't change. Those we just copy from what we had. Copy, copy, copy. But this has become my new and improved bottom row. 10 thirds y minus 13 thirds z equals negative 43 thirds. Okay, we're making progress. We got the 1x, that we like. We got no x's here, that we like. So now you move over and you make this into just a y. Make this into just a y. So we're going to change row 2 again. And I could say divide by this coefficient, the second row, second column coefficient, but I'd rather just say, look, I'm going to multiply by the reciprocal. So my new row 2 is going to equal 3/11 times my old row 2. And I can just kind of do that, I think. So let me just try to write this all at once here. X minus 1/3 y plus 1/3 z equals 10 thirds. Okie dokie. Now, taking everything in this row and multiplying it by 3/11. Well, the 11 thirds times the 3/11 will go boof. Turn it to a 1. 3/11 times 10 thirds. Well, the 3's will cancel. We'll have a 10/11 z. 3/11 times 23 thirds. Again, the 3's will, the 3's will cancel. So it'll be a negative 23/11. And the bottom row is still what it is. Okay. We're definitely making progress. Notice we got basically 2 steps to go to reach our final destination in terms of this simplifying the set. I forgot to put the y here. Let's put that back. Okay. But our goal now is to basically get rid of that. We want to get rid of the y term in the bottom equation. How are we going to do that? Well, we'd like to add equations together. So what I'd like to do is I'd like to add this equation, except make that y into a negative 10 thirds y. So negative 10, maybe I should write this this way. The new row 3 is going to be negative 10 thirds times row 2, adding row 3. So this gets a little bit juicy now. I'm going to try to multiply everything in this row by a negative 10 thirds. So that would be a negative 10 thirds y. Now when I multiply this term, I'm going to have negative 100 over 33z. Wow. Equals, and then here I've got a 230 over 33. Okay. And then what else we got here? Add the row 3 to it. So that would be the 10 thirds y minus the 13 thirds z equals the negative 43 thirds. So when we add those 2 equations together, the y's go away. Yay. Now adding negative 100 over 33 and then minus 13 over 3, I would have to use a common denominator of 33. 13 times 11 is 143, so it would be a negative 243 over 33z. Yeesh. Oh, lovely. Okay, so this one we have to make 43 over 3 into a common denominator of 33, which means that has to be a 3434, which means that has to be a 473 negative, plus the 230. That'd be a, oh my gosh, are you kidding me? Look what just happened. Oh gosh, that's lucky, and I'm glad we got lucky because these numbers are getting intense. So negative 243 thirds, or excuse me, negative 243 over 33, z is equal to negative 243 over 33. Z is equal to 1. But just to follow our method oh so precisely, I'm going to write the state of this system right now. Right now, the top equation is this. The middle equation is this. Oops, not thirds, 11ths. Okay, that was the middle equation, and this was our new form of row 3, right? That's what we were doing here. Our new form of row 3 is now, and this is kind of trivial, but negative 243 over 33z is equal to negative 243 over 33. So at the moment, that's the state of our little system of equations here. That's a 33. The next step, hopefully, is kind of obvious. We want to take row 3, and we want to basically multiply by the reciprocal here to make that just a z. So negative 33 over 243 is the reciprocal times row 3. And when you do that, you get something really nice. You're going to get x minus 1/3 y plus 1/3 z equals 10/3. Here you're going to get y plus 10/11 z is equal to negative 23/11. And our bottom row has become so nice. Z is equal to 1. Oh, you got to love that. This is our simplified system. Big smile. Once you've got your simplified system, and again, what makes it so simplified? That's just an x, and there's no x's underneath. That's just a y, and there's no y underneath. That's just a z. That's your magic form. Once you have the simplified system, you can basically, you can basically start assembling your solution. You look at the bottom row and you say, well, that's part of it. Z equals 1. And you kind of bubble up, so to speak. So you did that first. Now you look at this equation. You just kind of go back up the thing here. And you say, well, y plus 10/11 times z, but we know what z is 1, is equal to a negative 23/11. So if you solve this, that says y plus 10/11. So we're going to need to subtract 10/11 on both sides here, right? And that's a negative 33/11. And guess what? That's just a negative 3. So y equals negative 3. Woohoo! All this work with the fractions just to get these answers, these nice answers. Well, that's fine. So we got that, and now guess what? We come up to the top equation, and we plug into that. So I've got x minus 1/3 times y, but y is negative 3, plus 1/3 times z, but z is 1, is equal to 10/3, and we solve this one. So let's see now here. X minus a negative is plus. 1/3 times 3 is 1. That says plus 1/3 equals 10/3 over here. So x is basically equal to 10/3, and you subtract that 1/3 on both sides, and then to subtract 1 is the same as to subtract 3/3. So 10, 9, 8, 7, 6. You get 6/3, which, by the way, is so x is equal to 2. So the bottom line is, if you were to graph these three equations, and by the way, in order to, wherever they are, where are they? Here they are. If you were to graph these three equations, and by the way, when you have x, y, and z, you've got three-dimensional pictures. These are each equations of planes. They're like sheets of paper. They're planes oriented in various ways. Anyway, we've got three different planes. Those three planes will intersect at this one point. That one point is where all three planes intersect, and hence we call it the solution to the 3x3 system of equations. I hope that was somewhat enjoyable. So that's this is setting us up big time. Hopefully the next lecture is going to go rather nice. That's when we will look at the official Gaussian elimination method, which is going to look awfully similar to this.